So the second little part to this is you can also do division the same way you did multiplication. This, if you see a radical on the top and a radical on the bottom, basically you could put it in one giant radical. Remember, these are square root signs. They have the same little index in here, which is a 2. We never write that. You might have seen it in the ed puzzles. We don't write that though, because we know it means square root. So we could simplify this and just do 8 divided by 4. You can never, ever leave a radical. I don't know why I crossed that. That's supposed to say radical. I think I was trying to make a dot in the denominator. I can't spell. Oh my gosh. So you can't leave this here. This problem is not simplified. 5 over radical 5. Nothing you can't do. What you can do though is you can do something called rationalize. If I've multiplied this, really it's the same thing on the top and the bottom. So I'm really just multiplying this fraction by 1, which is perfectly legal. 1 times anything is just the anything it started with. So what it does though is it gets this answer in a different form. Square root of 5 times the square root of 5 is that. And I would even like it if you didn't write that middle step, because when you multiply a radical by itself, it just comes out of the radical sign. Oh, soccer practice going awry.
Sorry.
That's okay. Bye. Oh, hi. So radical 5 times radical 5 is just 5. And then if you get down to the end like this, those cancel. So your answer is just that. So you must rationalize. That's what that is called. So you'll hear me say it. Time in and time out. The other thing that you need to know is there's multiple ways to solve problems. So if you see me solving a problem one way and you decide to be creative and solve it another way, perfectly legal. So you can see I'm rationalizing. I'm doing that because there was a radical in the denominator. Square root of 6 times the square root of 6 is 6. You could have done radical 36, but it still comes out. And here, those cancel. So you get that. Now there's going to be 2 ways that you think about doing this. Some of you will think of it this way. Okay. And when you get there, you'll realize that you get that, which you can't leave like that. And you'll go there. That's one way. Other way is for you to rationalize here. Breezy! Oh, sorry, guys. I can't. Hold on. I'm going to yell. Bree, come here. You can't be out there. No soccer practice for you. Go lay down. Want to go outside? I'll send her out in the rain. So you guys get a beautiful tour here of my neighborhood. Isn't it nice? Nice neighborhood. Yeah, we got a little thing. That's some orange peels from yesterday. Anyway, I miss you guys. Okay, back to the math. So the other option to doing this is to realize, oh crap, you have a radical in the denominator, and you decide you want to rationalize it then. And you say, okay, so I'm going to multiply it by radical 12. Oops. So you get a 12. And here you say, ooh, there's a perfect square that goes into that. Square root of 4 times the square root of 6. Square root of 4. And look, isn't that the same thing? Either way. So it just depends on which way you see it. This is what I see on this one. That's equal to square root of 4. So I see this. So I see that. If you decided at the beginning to rationalize, you would have done this. You would have done this, which would have given you that, which would have given you that, which is the same thing. So either way, you can see I get 8. Last example. I'm just going to rationalize. Look for the biggest perfect square that goes into that, which I believe is just 4. Kind of garbage. You kind of want it to be bigger, but your answer to this, there you go.